Hi friends, today we're going to talk about graphing using slope-intercept form. Now, in my opinion, this is probably the easiest way and quickest way to graph a line. And you may be used to graphing a line by plotting points and then connecting them. And this would be the next step in your mathematic journey because it is more straightforward and usually a little bit quicker to be able to do. So let's talk about what slope-intercept form is and how it's useful to us. So when we say slope-intercept form, we really mean y equals mx plus b. And in a previous video, we talked about how the m represents the slope of that line. And remember, slope tells us about how much it changes left to right. Is it a positive slope that goes up? Is it a negative slope that goes down? Or a horizontal line with zero slope? All right, the B part is new. This is what's called our y-intercept. And that is just a fancy way of saying, where does it touch the y-axis? Remember, the y-axis is our vertical axis. And so y-intercept just means where does it touch? Where does the line touch the y-axis? Okay, so let's make a plan. When I have a line in y equals mx plus b form, and just a note, your first step is to solve for y, which we just did in a previous video. Check back with that one if you did not watch it. All right, so the first thing we're going to do is solve for y so that we are in y equals mx plus b form. Okay? And so then when we look at it, we will know that the coefficient on x describes our slope, and the constant describes our y-intercept. And I like to label those once I have solved that equation for y. I like to write down what is my slope, what is my y-intercept. Then our next step will be put the y-intercept on the graph. So this is going to be a point that we place on our graph. And then our third step is use the slope to get to the next point. We're going to plot it, and then we're going to connect them up. Because 2 points determine a line. All right, let's look at an example so we can see how this works. I'm going to give us a straightforward example to get started. So we're going to graph y equals 2x plus 1. Now you'll notice the first step is already done for you. It is already solved for y, so I don't have to do any rearranging. I can go ahead and read off of this graph the slope, which is going to be 2. It's the coefficient on x. And my y-intercept, which is 1. So that tells me my slope, and we write it as a fraction, my slope is 2 over 1. That means from any point to get to the next point, I can go up by 2 and right 1. If it's positive, we go up. If it's negative, we go down, but we always move to the right. All right, and then my y-intercept is the point 0, 1, and that comes from the plus 1, the constant term on the end. All right, let's graph it. So I'm going to draw my x-axis, which is the horizontal line with an arrow to the right, and my y-axis, which is a vertical line with an arrow on the top going straight through that x-axis, and they are perpendicular. And I'm going to mark off a few units in each direction on both the x and the y-axis, starting from the origin. All right, so let's start, obviously, by putting the y-intercept on the graph. So my y-intercept is the point 0, 1. So I will start at the origin. I will go 0 units in the x direction, so I won't move, and then I'll go up 1 in the y direction, so I have a point at the point 0, 1. Now, from that point, I'm going to use my slope to get to the next point. So we will go up 2, right by 1, and place a point. That point will be at 1, 3. And then I will connect them with a straight line to have a graph of the line y equals 2x plus 1. Now your teacher may not require you to label the line on your graph, but I like to, just for good measure. Okay, let's look at another one of these. And again, I'm going to do one that is already solved for y. If you needed to solve for y first, you totally could. All right, so my line that we're going to graph now is y equals negative x plus 2. And you might say, there's not a coefficient on x. What's the slope? Remember that we have a sneaky coefficient of 1 right here in front of the x. So my slope, remember that the negative stays with it, my slope is negative 1 over 1. And my y-intercept is found by looking at that constant term of 2. So my y-intercept is the point 0, 2. All right, let's graph it. I'm going to move right over here to the right to save some space. So I'll draw my x and y axis. X is my horizontal line, y is my vertical line. And I will mark off a few units in each direction starting from the origin. All right, so remember we always start with that y-intercept where it intersects the y-axis. So my y-intercept is the point 0, 2. I'll start at the origin. I move 0 units in the x direction and then 2 units up in the y direction. So I have a point at the point 0, 2. And then I'll use my slope to plot the next point on the line. So my slope is negative 1, which we think of as negative 1 over 1. So I will move down 1 unit and right by 1 unit. Remember that negative tells me to go down on the graph, and the 1 in the bottom always moves to the right. So I can connect those points into a line with arrows on both ends. And I've graphed the line y equals negative x plus 2. Because it has a negative slope, we would expect the line to be going down as we move left to right. All right, let's look at another example. I'm going to do y equals negative 2/3 x minus 2. Lots of negatives in there. Don't worry, we got this. All right, remember that slope is the coefficient on x. So in this situation, slope is -2/3. Okay, it is negative. It'll be going down from left to right. And then our y-intercept, would be the point 0, -2. Remember that that negative travels with the 2. They are attached to each other. All right, so let's draw a graph. Same as before. X-axis is our horizontal axis, y is our vertical, and they intersect at a right angle. And I'm going to mark off a few units in each direction. And hopefully you're using graph paper to do this, so your graphs will be more exact than mine, since I'm kind of freehanding this thing, but all graphs are truly a sketch to represent the line that we are talking about. All right, first step, we're going to start with that y-intercept. So we want the point 0, -2, so I'll start at the origin, go 0 directions in the x, and 2 down. So my point of 0, -2 is the first one I'll put on the graph. And then we will, from that point, use the slope to get to the next point. So my slope is -2/3. That tells me I'm going to go down 1, 2, and then right by 3. Let's make sure I'm accurate here. And I'll put the next point down. So that will land at the point 3, -4. And we will connect those up using a straight line. And that's the line y equals -2/3 x minus 2. Okay. As you can see, this is a lot quicker than creating a table and plotting points. And as you get to graphing more and more lines, it's helpful to be able to use this method as a way to quickly graph. If you had a more complicated statement of y in our problem, then the solving for y would be very important. If you need to look back at that, I do have a separate video on solving for y to be able to get you through that step so that you can read off the slope and the intercept and move forward with the graph.